Welcome back, everyone. In this video, we're going to be introducing the C programming language, an older and lower level language that looks something like this. And if you've never seen code or worked with this language before, this is going to look incredibly cryptic. However, if you look close, you might be able to glean what this code is going to do. And in fact, it's just going to print out "Hello World" onto the screen, which is typically the first program a programmer will write when learning a new language. Now, there are all these strange curly brackets and this hash include up here and this int main void, which all looks really confusing. But we'll tease this apart, and in time you'll understand everything that's going on here. For now, though, I want you to focus just on line 5. This printf hello world \n, even that has a bunch of strange characters you might not be familiar with. But let's break this down and see exactly what's going on here. If you've been following along in the playlist up to now, then you've seen this model from time to time. And when we first introduced this, we explained it as being a model for solving problems. We've seen some examples of this, such as this being an algorithm. However, now we've transitioned into calling this black box function, or really the implementation of an algorithm. And these functions can take inputs, and they can return outputs. So how is this relevant to this printf line? Well, printf is just a function. It's an algorithm that someone else has implemented and given us the ability to use. This is similar to that car example. Like, you don't need to know exactly how the car's engine and transmission works to drive the car. You just need to know how to drive the car. Similarly, we don't need to know exactly how this printf function is implemented. All we need to know is how to use it. And the way that you would use this printf function is that you would call the printf function by typing its name, printf, followed by open and close parentheses. And inside these parentheses, you can supply an input to the printf function. The input that printf expects you to give it is what's known as a string. And a string is just anything between double quotes. For example, quote unquote hi is a string. Quote unquote hello world in our example here is a string. A string is just a word, or a sentence maybe, or even a whole paragraph. But a string is just a sequence of characters inside double quotes. So printf is going to take this string, hello world, and it's going to print it onto the screen. There's something else to notice here though. You might have noticed this \n after the hello world, and then this semicolon at the end, and wondered what's up with that. Well, typically we're going to end all of our statements with a semicolon. This is similar to how we would end a sentence in English with a period, and we're going to talk more about this in later lessons, but just know that we need to use this semicolon here to essentially finish our thought. Now this \n is what's known as the new line character, and it's just a special character that's going to move the prompt to the next line. And we'll see some examples of this soon. So this is hello world, and perhaps one of the simplest programs that can be written in this language called C, which is just going to print some text out to the screen. But with this, it seems we've kind of backed ourselves into a corner. Because what did we say is the only language that a computer can really understand? Well, binary. That's right. Our computer doesn't understand anything else besides binary. And this program that we've written is not binary. We have these special characters like \n, and so it would seem that we need a way to convert this code that we've written into binary that the computer can understand. Unfortunately, we have a program to do exactly that. This program is called a compiler, and its sole purpose is to take code that we have written in a language like C and convert it into binary. And we'll bring this model back. The program is called a compiler. It's just the implementation of an algorithm. And we can pass as input to this program a text file containing the code that we've written out using this language called C. And it's going to return to us a new file containing the zeros and ones that the computer can not only understand, but also execute. And we've talked about how computers can use binary or these patterns of zeros and ones to represent data like numbers, letters, and colors, etc. But with these patterns of zeros and ones, we can also represent instructions that the computer can understand. Because at the end of the day, our computers are good at performing operations such as addition, subtraction, moving things in and out of memory. And the compiler is going to take care of mapping the code that we've written into some patterns of zeros and ones that the computer can execute. And again, we don't have to worry too much about the implementation of a compiler. We just need to know what it's going to do and how to use it. Now, the technical term for the code that we, the human, is going to write from here on out is going to be known as source code. The actual zeros and ones, or the binary file that the computer understands, is going to be known as machine code. So humans write source code, a compiler translates our source code into machine code, and the computer is going to execute that machine code. So let's do this for real. Let's actually write out this Hello World program, compile, then run it. And I'm here in my Ubuntu virtual machine, and the first thing I'm going to do is open the terminal. I'm going to use the ls command to list out different folders, files, this directory. You can see here that I have this directory called tutorial that I created in the last video. If you don't have this directory, you can create a new one using the command mkdir followed by the name of the directory. In my case, I used the mkdir and tutorial. So now we're going to use the cd command to change into that tutorials directory. We do that by typing cd tutorials. I'm going to open up Visual Studio Code in this folder. I'll type code, space, and a period. Now VS Code is going to open. I'll create a new file in here. Instead of this test.txt, we're going to call this hello.c. This .c is important. When we write our source code, we want it to be in a file ending with .c, so that when we go to compile this, the compiler knows that this file has C code written. Now I'm going to type this out from memory. I know we haven't gone over all this syntax, and we will, but let me just type it out and then we'll go over it. Then I'm going to save this file using Control S, keyboard shortcut, or I could come up here to File and click Save. Either way works. So I have this source code now. I need to run this source code through a compiler, get the machine code. The way we're going to do this, we're going to go back to our terminal, and we're going to run the following command. The name of the compiler that we're using is called GCC. It's a very common compiler, although there are other compilers that you could use. Clang is an example of one other compiler. But in our case, we're going to use GCC, followed by our file name, which was hello.c. And if we typed everything right and we don't get any errors, it would appear that nothing happened. But now if we type ls to list out the files, we're going to see that we now have this file right here called a.out. And this file contains the actual zeros and ones that the computer is going to be able to understand and execute. And to run this file, this may seem a little strange, but we're going to type /a.out. Hit enter. And we'll talk about this / notation a little bit later. But essentially, this is a way of saying I want to run a file called a.out in my current directory. So congratulations, you just ran your first program in C. Let's look at a couple final thoughts before wrapping this video up. Let's go back to our file called hello.c. Instead of typing hello world in here, type in hello universe. And then we'll save the file. Then we'll come back to our terminal and let's try to run this again. What happened here? It's still saying hello world. Why? Well, that's because we didn't recompile it. This is to say that every time you make a change to your code, you have to recompile it. So let's run gcc hello.c. And again, we get no errors. So let's type ls. And we see that now we still just have this a.out file. So if we already have a file called a.out and we run gcc to overwrite that file. So now if we type /a.out, we're going to get hello universe. And a.out is a pretty stupid name for a program, so let's see how we can change it. It turns out that if you read the documentation, GCC, this compiler, can take more than one argument. The only argument that we're passing to GCC right now is the file hello.c. But we could also run this GCC like this. We could say GCC-O, and then the name of the output file that we want it to make. In our case, say hello. And then we supply the C file of hello.c. If we run this, type ls again, we can see that now we still have this a.out file, but we also have this hello file. And this is highlighted in green just to kind of indicate to the user that this is a binary file that we can run. So now if I do /hello, type in, you see we have this hello universe. And now I kind of don't like that I have this a.out file here. Let's remove that. And the way I remove a file in the terminal is by using the rm command for remove, followed by the file, say a.out. When I hit enter, then run ls again, see that a.out file. In this video, we learned how we can write a simple hello world program using this older and lower level language called C, and we learned how we can take this source code written by us and convert it to machine code, which the computer can not only understand, but also execute. In the next video, we're going to start to tease apart this program a little bit more and start looking at some of these common constructs in this new language, like variables, loops, conditionals, functions, and much more. Thank you all so much for watching. I hope you got some value out of this video, and I hope you're excited to keep learning and to start writing some more complex programs.